Looks great to me.
Okay, perfect. Okay, so last time we touched briefly on this idea of aspects at the end. We were talking about fiber refs, and we spent a little bit of time on this idea that aspects were a nice way to expose modifying a fiber ref for users' code. And we really quickly did an implementation of an aspect to show that, but we did it pretty quickly and it had a lot of type parameters. So we thought that it would be nice to do a session where we just really dove into this concept of aspects and said, what are they? How do we implement them? And we really went through the implementation of them and hopefully get you to the point where, one, you really know what aspects can be useful for and when you might want to turn to aspects when you're using existing ZIO code and know where to turn for that, but also know when maybe this is a tool that makes sense for your own data type of, if you have a HTTP data type, what would it mean to have an HTTP aspect and why might you want that? And if you did want that, how would you implement that? So to start out, the way I like to think of aspects is they take care of the how of what we're doing. So whenever we have an effect, we could divide it up into two things. We could say there's what we're doing and there's how we're doing it. And so a simple example might be, if I have something, my ZIO here, that's, let's just say it's ZIO any nothing int. And in this case, it's a really simple effect. So it's 42, but maybe we don't even know that. So the what here is we're producing an int. And we're already accustomed with a lot of ways to transform that what. So I could say if I have my ZIO2, maybe this is going to be a string. And maybe this takes my ZIO and it just stringifies this thing. This map is one way to transform the what of what we're doing. And a lot of the operators we're familiar with that we use, I would say most of the time, are dealing with that what, if we're mapping or we're flat mapping or we're zipping or we're erasing. But there's another set of concerns, we might say, about how we're doing it. So if we say what we're doing is maybe we're returning an int or we're transforming an int to a string. For the how we're doing it, we could ask a ton of other questions. If we could say, what executor are we running on? We might say, what yield op count are we using before we yield in the runtime? We might say, what logging context are we in? These ones are more general to ZIO. If we think about more specialized domains, a lot of times we can think about a lot more of these things. So if we're talking about the domain of streams, another aspect of this how might be, what chunk size are we using? Another one here could be, what parallelism are we using? If we have testing, we might say, how many times are we repeating tests? How large are our property-based values? How many samples are we looking at? Maybe we might want to say, like, should we log console output, or should we just say, well, we're going to test that, but we don't need to kind of show this. So there are a ton of things like this. And a lot of times it can be helpful for us to separate out those two parts of what we're doing so that one, just kind of visually for us to reason about it, it's easier for us to do that. And two, sometimes it can give us more of an ability for us to refactor our code. So like we might imagine if we have something like, maybe here I would do like on executor, and I want to run it on some executor, and then I flat map it, and then I maybe take this thing, and I'm just gonna add an exclamation point to it. But you see here, I've like started to kind of mix up my logic of what I'm doing with how I'm doing it. And I have to be like a little bit careful here of like here right now, at least the way I've written this, I'm saying, well, run this thing on this executor, but don't run this other thing on this executor. And if I wanted to say, well, maybe I want to do some different thing about where I want to run it or what I want to do, I've kind of got to like dig into this code and see that. And so the idea of these aspects, and probably where you might have been most familiar with them is like from ZIO Test, is they kind of almost starting at a point, even visually, just start to separate these out. So like here, I think we have this. Yeah, I can do ZIO aspect on executor. And so you can almost think of this as like a visual indicator of here's the what, and here's the how. And that also makes it really easy for you to change the how. Say, well, maybe I don't care about this at all. Delete it. Or it also gives you the ability to factor this out into something else. So we might say, val my aspect is going to be ZIO aspect on executor. And then let's find another aspect we can apply. Yeah, let's play with our parallelism. And let's say we want to use parallelism of 4 for that. And now this my aspect thing, this describes all the parts of the how I want to do. And I could use these maybe in multiple places in my application. And if I ever decide, well, I actually don't want to do parallelism 4, I want to do parallelism 8, or I want to do something else, or I want to run on some other executor, I can change it here. And then anytime I'm calling this my aspect thing, I'm going to apply those things. So that's the concept of the aspects, is really this idea of separating the what from the how. Does that make sense for people? Let's see. Okay, we got lots of Discord links.
Yes, yes. And in the Discord itself, Adrian and Naveed say, yes, it makes sense, and that it looks aesthetically pleasing.
Huh, lovely. I'm probably not as good at you as making things look aesthetically pleasing, but I strive for it. So I appreciate that. So, okay, we've got this like idea of like, oh, this is like nice. We like get to use these @ats and we have these aspects, but there's also like, I think at this level, you might, like a lot of people may have already used aspects of, especially with ZIO Test, you probably maybe use like ignore or non-flaky or flaky, or some of those aspects kind of end up being very commonly used. But like, if you look at them, they can also be like a little bit maybe intimidating, of like, you look at this like ZIO aspect thing and like, boy, it's got like 6 different like type parameters, and like, what's going on here? And like this thing, this all has like all of these bounds, like this is like super long, like what is this? So let's get a little bit more into like what this is, so we actually understand this better and we can implement ourselves if we need to. And we can also see how like the type signature is actually almost enforcing for us this distinction between the what we're doing and the how we're doing it. So the basic idea of all of these aspects, and maybe I'll just implement our own, and maybe I'll call this, I'm just gonna call this a Z aspect, just so it's different than the ZIO aspect, so we can kind of implement our own here. And we're generally, for whatever type we're implementing the aspect for, we're going to have two type parameters. We're going to have an upper and a lower bound. And so like in the case of ZIO, we have 3 type parameters. So a ZIO aspect would have 6 type parameters. If we had something like, I think an HTTP app just has like 2 type parameters, just like an environment and error, then a HTTP app aspect would have 4 type parameters. And this is one where I think sometimes, like a lot of times we just use the R, the E, and the A, but I think sometimes it can be helpful to actually have like longer type parameter names. It makes things a little bit more verbose, but I think it can also make it a little bit clearer when we're like doing things that are not the most simple. So I think a good naming convention maybe we can use here is we're just going to use lower and upper. So our mechanics are basically going to be, if we've got a ZIO REA, then we're going to translate that into a ZIO aspect, or in this case, I'll call it a Z aspect, lower R, upper R, lower E, upper E, lower A, upper A. And then this is going to have this one method that I'm going to call apply here. And this lets me take a ZIO effect that's a ZIO REA like that. And it's always going to give me back a ZIO of that same type. But I'm going to put some constraints on each of these type parameters. And so for each of them, and this is where having to being verbose and having the lower and upper helps me out a little bit. I'm going to say the R is bigger than the lower R and the subtype of the upper R. And we'll come back to this in 1 second. We'll kind of go through a little bit more of the interpretation of each of these. We'll say that E is a subtype of the lower E, or a supertype, excuse me, and a subtype of the upper E. And we'll say that A is a supertype of the lower A and a subtype of the upper A. And let me just make sure that this gets some auto compilation going. So we check ourselves here. So what this is saying is this ZIO aspect can take any REA that's within these bounds, and then it'll give you back the same REA. So let's start with the simplest example. So the easiest case is where we don't do anything with any of these type parameters. And so like, let's think about that like on executor example. So I could implement a on executor aspect that takes an executor, and it's going to give me one of these Z aspects. And I'm just going to do this just for a sec so we can kind of do this interactively together. Okay, so let's build up our intuition a little bit for this. So what should this lower R parameter be? Is there any constraint in this case on what environment type of an effect that I could accept with this? I think
people are saying, no one said anything, but I don't think so.
Yeah, that's right. There's no environment that would have too many things for us to be able to shift the executive, for us to not be able to shift the executive of the ZIO effect, right? If we kind of think of like, let me make up an effect that needs a database and logging and persistence and Cassandra, like I could still take that same effect that needs all those things and run it on an executor and get back a new effect that needs the same things. I'm not able to like provide any of those things, but like whatever it needed originally, it's still going to need afterwards after I provide it with this executor, and it doesn't matter what it is. So this first one can be nothing here. Okay, how about this top one? Is there any environment type that would be too general that I couldn't use this? Like this is the upper. This is, if we think of nothing is the lowest possible type, and any is the highest possible type. We have this a little bit elevation interpretation of types. Would there be any problem if this type was any?
Another way of saying this is lower is sort of the most specific, and the upper would be the most general. And I would also say, yes, there is no generalities ceiling here that would prevent such a thing.
Yeah.
It might be worth, maybe once we've finished populating these, but sort of, I'm sure we will look at some examples where there is an upper or lower bound, because I think it'll help build the intuition for what does that really, what does it mean? Yeah, I've personally speaking, I'm sure a few of our viewers have never quite used both lower and upper bounds. Maybe we're used to upper bounds. Maybe some people have used neither. I've used a bunch of either lower or upper bounds. Generally for contravariant types, you use the upper bound and maybe lower bounds for covariant types, but yeah, never quite did the opposite in those situations. So it's interesting to see how why that is so useful or necessary.
Yep. So that's exactly right. So this can be any. And we can apply some of the same logic here to the error and the value types. So all I'm doing is I'm taking the executor and I'm changing it. I'm not doing anything with the error type. I'm not doing anything with the value types. So you can give me any type, but I'm going to give you the same type back. And another way we could test ourselves on this is we could just look at the implementation of this on executor method. And let's see if this will go here. Yep. And so we could notice here that other than this trace thing, which is a little bit of just, we'll come back to that slightly in a second, this thing doesn't have any constraints on what the R, the E, or the A is. There's no like implicit evidence that the R is this, or no widening of the R or the E. It's just whatever the REA is, we're getting back the same REA. So that's another clue that we don't need any constraints on these types of the aspects. So here we can just, do a little bit of just plugging these guys in. Okay, let's see. Yep. And then one nice thing is that the Scala compiler, if something's a super type of nothing, you're not really saying any new information about it. And if it's a subtype of anything, you're not really saying any new information about it. It's like saying you're less than infinity, or you're greater than negative infinity. Though there's probably some mathematician would say there are different infinities and some are greater than the others, but we'll put that aside for this exercise. And so we could actually, like, just if we want to make this simpler, we can delete these, though we might also say, well, it's, at least while we're learning, it's nice to write these out just for the symmetry as we have more, but this will be completely fine too. And so when we look at this a little bit, we can start to see this idea that this signature is forcing us to deal with the how and not the what. And the way that it's forcing us to do that is it's stopping us from knowing about the what. So like this is the extreme case, and we'll look at some cases where we know something about these. But in this case, we don't know anything about what any of these parameters are. So like if we wanted to do something with the A, we really couldn't do something with the A even if we wanted to, because we don't know if the A is a string or an int or a double or some kind of case class. So there's nothing we can do with that part of the what. And a similar, like if we think of the E as maybe another part of the what we're doing, of maybe want to handle that error or do something with that error, we can't really do anything with it here. So we're forced to work with these things that are more about the hows, that aren't changing these types, but aren't transforming them, but are just specifying some aspect of how they're getting computed. Does that make sense?
Yeah. I mean, it's the sort of the rules of parametric polymorphism.
Polymorphism,
right?
exactly.
Parametricity.
Parametricity, exactly.
Okay.
So let's then start to think about, like, so far, as you were saying, Kit, if this is all we're ever going to do, then we actually don't really need any of these type parameters here. We could have like a really simple one that basically doesn't have any type parameters and just always gives you back the same type. And we could actually implement like a decent number of things. Like we could implement this like on executor thing that way. We could implement something like saying maybe like what chunk size we're using, because that would just be rechunking it. But let's play with another example. And maybe here it'll be helpful to have at least a simple implementation of our logging service. So remember last time we played with this logging service, and I think we had a pretty simple interface there that we said with the logging service, we could either log a line, or we could, I think we called like with annotation. And we wanted to be able to add these log annotations that in this case were just these key value pairs. And so this is going to say, well, if you log anything within this ZIO effect, make sure you log it with this information of it was in the context of this key value pair of these strings. So now let's say that we go and we try to implement another aspect here of, we've said, okay, it's nice to be able to say this how of like we want to do on this executor. We'd like to have another how of we'd like to do it with these log annotations. And so here, let's say we'll call this like with, or maybe we'll just call this annotate. And so this will have a key, it's a string, and a value that's a string. And let's play with the same signature we had here, just to see what happens when we do. So in this case, I don't want to run it on this executor because I don't even have an executor here. But I want to do, oh, and sorry, I'm going to do one more thing here. I'm just going to do a accessor for this, just to make this a little bit nicer. That. All right, there. Yeah, exactly. We need a tag here, I believe. Oh, or we just need to specify this is. Okay.
We might actually have to, is that working?
Sorry, what's that?
Is that happy there? Okay, good, good.
Yeah, that's good now.
Okay, good.
Yep. Okay, so now clearly we don't want to do on executor because that's the wrong implementation. So I'll start with a question mark. And so now what I'd like to be able to do is I'd like to be able to say, well, this should just be logging dot with annotation key value ZIO. And this illustrates a common pattern that a lot of times these aspects are really going to give you just a nicer way to export operators that may exist somewhere else. And a lot of times there's not necessarily a lot of implementation logic in the aspect itself other than understanding these type parameters and there being a lot of them. But let's look at what happens when we try to do this. So we're getting a compilation error here, and it's saying type mismatch. It found logging with REA, and it required REA. And if we think about it for a minute, we can see that that's true, that going back to the signature of this with annotation thing here, it's adding this constraint that this has logging. And we can actually really express this one of two ways. We can either express it as the subtype bounds here, or we could express it like this. But either way we do it, this thing is taking whatever this R was, and it's saying, well, now whatever that R was, it also requires logging, because the whole point of this method is we're going to access the logging service and we're going to add this annotation. So there's no way that we're going to be able to do that if we don't have a logging service. And so this down here is telling us like a real thing. This isn't just like some annoying, like, oh, we can as instance of and it'll be fine. This is saying this thing is always adding logging to the environment. And so we can't honor this signature of you give me a ZIO REA and I'll give you back a ZIO REA. Because like, what if my ZIO was like a ZIO any nothing int? And now I want to take this ZIO and I want to apply this annotation to, or this aspect to it. So clearly I can't get back a ZIO of any because this thing needs logging. So if we don't have any of these type parameters, we're limited to these things that really can work on absolutely any effect at all. And there are definitely some of those, like this on executor one. We could like rechunk things. We could maybe change runtime configuration. There's definitely like a set of things that we can do with that. But there's also a whole big set of them that we can't. And the first one is we can't essentially use anything that requires an environment to modify this aspect of how we do things. And if that was the case, that would be pretty unfortunate because a lot of times we want to use the environment.
Could I add a brief aside on intersection types with regard to subtyping?
Yeah, please.
Cool. Yeah, just because you know it's not necessarily an obvious thing. Get a little tricky to think about. Probably went over it before when talking about things in the environment. But for instance, you know, one way of thinking about subtyping, whatever subtype super, would be that.
There we go. Perfect.
Oh, sorry. Yeah, would be that the subtype.
No, my bad.
The subtype is sort of a is more specific than the supertype, and then supertype is more general, which makes sense. You know, if you have a trait animal, trait dog extends animal, all that stuff, right? Animal dog is a subtype of animal. Animal is more general, right? You might have mammal above that or whatever, or in between. Dog gets more specific in whatever. A particular breed, a hairless flaming dog. It's not a real dog breed. Is a more specific variety of dog. And so yeah, general, more specific. So the question might be, it can get a little confusing if you know we have these things like logging and database or what have you. Logging with database, it might be confusing how this relates to, let's say, any, or you know, question mark, what's the relation? Let me do a confused looking or an angry face, right? Like what goes here, or what's its relationship to logging? And it can be a little sometimes difficult if you just think higher or lower, like which one's a super type? I don't know. But if that's why this more specific, more general approach can be a nicer way of framing it, because then you could say, well, this is certainly a more specific description than this. And indeed, that would mean that this is a super type. That this is a subtype of logging. Logging with database is sort of a refinement. It's a specification on just logging. It's not just logging, it's logging with some more details. So any would be very vague. Logging would be more specific than anything. And then as you add to the intersection type, it becomes more and more of a supertype. So any sort of extension of an intersection type would be a subtype. Now, if it's sort of with, I don't know, something else, if it loses something, it's not a supertype anymore. It's kind of it's not part of the hierarchy any longer if it's totally different. But yeah, hopefully that can help understand a little bit how we're using these constraints. Is that you can think of these subtypes as being more or less general, or having more requirements in the environment or fewer requirements in the environment, all the way up to no requirements in the environment. And then at the bottom, I guess, I don't even know if that makes, I don't think that's not even a possible thing in this case.
Yeah.
Or I guess it is a possible thing in this case.
Yeah.
Oh yeah, it's more, because we're saying whatever we care about is going to be greater than nothing.
Another way I sometimes, some of these just depend on how you think about it, but another way I sometimes think about it is like, if you think about it in terms of information, any is a type that has no information. So if you think about it as like a trait, it would be like a trait that had no methods on it. Like there's nothing at all you could do with it. And that's why sometimes we say that, like, if I had any, I could always provide unit, or I could provide 42, or I could provide a dog, because I'm literally like, if I said like trait my any, it's this. And so if as long as we're not like cheating and doing things like as instance of, like, I could give you anything for this thing because this thing has no methods. And similarly, you can think of nothing, or we'll call it like my nothing. This would be the trait that has every method that could every method in the universe, right? So like this is something that has some method that says whatever the price of Bitcoin tomorrow, and it's going to give me a double that, and it's going to have an implementation for that. And clearly, like, there's no thing that's going to have an implementation for like every possible like method that like could ever exist. So that's why like this thing never exists. So that's just like again, different way you could think about it depending on what works best for your brain.
So no information and all of the information in the universe.
All the information, exactly, and nothing can have all of the information.
Yeah, nothing's a bit of a paradox, but useful, like 0 is in terms of numbers.
And one other thing that can be helpful here is, like, it can be good for you to just take a little bit of time and play with this if you haven't before, and you can check yourself by using this implicitly thing. And you can use implicitly with this arrow colon arrow to basically check yourself on something. So like if I want to say, is logging with database really a subtype of logging? And this will actually give you a compilation error. I'm just going to comment this out for a sec, just so we kind of are compiling or not compiling for the right reasons. But so look at this. So this compiles okay. And this compiles in a little bit of a like logical or computer science type way. If it doesn't say it's not, it says it cannot prove that it is, which is technically accurate. But this is a really nice way that you can test some of this yourself. And if you want to, you could even make a little like helper for yourself. You could do something like is subtype left, right. And in this case, I'm just going to have this return units A, because it's really just going to be about whether it compiles. And I could say subtype of right. Yeah. And so now you've got like maybe an even like clearer for you thing of like, anytime you have a question, you could just do this thing. And if you wanted to, you could even have another one. You could have is super type. And so this can just be a nice way of we're using the same tools in the Scala language. We're not doing anything differently. We had that implicitly, but like now it's a lot more clear in plain English of like, you can just check these things and you can verify for yourself whether your intuitions are right, or you can adjust them as necessary.
Yeah. Oh, and I guess since we're going down this path, one more is same type, right? We can have a second bit of evidence too of left. And technically, there's another operator for this, but if it's both, then it has to be the same type. And we can actually check here that is it the same type if they are in a different order. That could be interesting. And it is. It's commutative, sort of, but at least at the type level, which is why we use it for certain things, because it's pretty nice that it has that commutativity.
Yeah, perfect. Okay, any questions on just subtyping before we go back to aspects?
Bill posted a good GIF, but no questions.
Okay, I will come back. I will appreciate the GIF a little while. Okay, so let's go back to this thing. So we had this compilation error here that we said this signature isn't going to work for us because it's saying we're going to take any R and we're going to give the same R back, but this with annotation thing is adding logging to it. So this is probably the first obvious case where one of these constraints comes in. And one way to think about this is we're imposing an upper bound here. We're saying that we need at least logging here. And now let's see. Is this? Say R is a subtype of logging.
Is it the lower in the right place in the upper? Is it lower than upper? Yes.
Oh, hold on a second. I think I may need my.
I think it says this needs to say with logging, but that doesn't make any sense. What's up with that? Oh, yes, the trusty
variance. I think is no, that's still not. Let's try going back to your original formulation of this.
But that should work nonetheless, no?
Should work, yeah. I feel like we're doing something.
Let me check the.
We have like two. Oh, hold on. I think we have different loggings here.
Oh, yes, that's my bad. Yeah, that's totally it.
Okay, and let's, I mean, this was all lovely, but we will.
Yeah, delete.
Comment this out for now.
And I'll change the accessor back to how.
I think either way should be fine there. Okay. That's another problem with too many. Logging is too common for these examples. Okay, so let's go back to this. So we were able to solve that problem by adding this upper bound on logging here. And one important thing to keep in mind here is this is saying this R type is going to have to be a subtype of logging. But let me show you one thing with this. So let me say, and maybe let's.
Yeah, we could just delete all that stuff, I think.
Yeah, let's just, or at least copy it somewhere else, just because I want to have a little more space to have these examples. So I'm going to push this maybe down here.
Okay.
And I'll just make sure.
Okay.
Okay. So let's say I've got this annotate thing. So let me say, my aspect 2 is going to be z_aspect.annotate foobar. And so notice this has these expected type parameters of nothing logging, nothing any. Question for us, am I going to be able to apply that to ZIO with this ZIO aspect? So this one says it needs as an upper bound of logging. This one has any. so am I creating a problem for myself? Like if I screwed myself up because I'm not going to be able to annotate this thing? And the answer is actually no, because of variance. So if I do my aspect 2, my ZIO3, this is actually completely fine. And if and if I look at the signature of this, it's added logging to it. So another way of thinking about these aspects is they have the ability to add a requirement to the environment, but they don't have the ability to remove a requirement from the environment. And that ends up being nice because a lot of times we're going to apply these annotations, like this aspect, to an effect that we may not know whether or not it needs the logging service. We say, like, whatever you're doing in here, if you are using logging, make sure that you're doing it with these annotations, but we're not saying you like have to have logged something. And so this is another illustration of some of those principles about subtyping of in ZIO, since the R is contravariant, we can always make that more specific. So as a really simple example, if I have this thing that says any nothing int, I can always do so I can always treat something as requiring more than it actually does. In this case, it's not actually going to use the logging service, but there's no harm in saying, other than maybe other things are going to be less accurate, but it's perfectly fair for me to say, well, maybe I do want a logging for this. I may not do anything with it, but I can still require it here and I can use this.
And likewise, you can also widen anything that's
the error
coded,
type.
right? So I can lie either way. So yeah, that's the cool thing about variance. You can narrow, you can specify, further refine contravariant types, or further widen covariant types, which makes it nicer to work with and compose more neatly without you having to widen and narrow everything manually. Okay, and so that's because of the contravariance on the environment that allows that to work, and it has nothing to do with the contravariance annotations you added on the Z aspect in this case.
Right. I think that was like a good thing to do in general, but yes, the problem we had was that we had a separate instance of logging that was totally different.
Sure. Cool.
Okay. So we've seen the use of a lower bound, and we've seen a use of something with the environment type here. And that turns out to be really important. Like so far, like having this like bound on the environment basically means we can use services in these aspects, which a lot of times we want to do, of like, we want to, here we wanted to use the logging service and we wanted to apply these annotations. Or in ZIO Test, we want to use the size service and we want to modify the size of these generated values. Or we want to use the test console service and we want to tell it not to print out to the console or to print out to the console. So that ends up being one really important set of things that we want to be able to do with aspects that get enabled by having those parameters for the environment type there. Another thing a lot of times we'd like to be able to do with the environment, or sorry, not with the environment, but with aspects, is we'd like aspects to be able to have some concept of failure. So let's try another aspect. And maybe I'll call this, I'll call it render console maybe. And so if we describe first what we want this to do, we'll say this should be an aspect that renders the success value of the effect to the console. And so we might start with something that's relatively similar to this guy here. And so let's say we want to do things by the book in the ZIO way. So we're gonna not just do like print ln, we're gonna kind of we're gonna actually use the ZIO service here. So we'll use the console instead of logging. And so here I might do ZIO.tap a console.println. Okay. And so here's another one where we've gotten a compilation error. And in this case, it's got the console, which we've taken care of the console here. But we've also got this IO exception floating around. And so why do we have this IO exception? Well, we have the IO exception because the console print line could fail. And that's reflecting the nature of the console print line, that it has that IO exception right there.
Mm-hmm.
Now, in this case, we could probably we could just or die it, or we could do something else with it to just make it go away. But let's say maybe this, in this case, it's almost so simple, but maybe this is actually supposed to write to a file. And we don't want to necessarily forget about this error. We don't want to just ignore it. Maybe we don't want to translate it to fiber failure. We want to make it part of the error type. We want to do exactly what this tap thing does. Notice that if we look at the tap, it says that there's this new error type that's more general than the original error type, and that this new effect that we're tapping it with can fail with the more general error type, and we want to return that more general error type. So if maybe our effect can fail with a domain error that extends throwable, and this thing can fail with an IO exception, then we want the whole thing to fail with, say, a throwable. But right now, we can't really express that because we're just saying we can work with any error type. And again, that's not true. If the original error was nothing, and now this thing can fail with an IO exception, we can't return an error type of nothing. And so the way we can deal with this is we can use this lower E parameter. And so here I can make this an IO exception. Oops, IO exception. And now this compiles. And so we've got a similar thing as we said before with the environment of the console of now if I've got this render console, and let's take this my ZIO3, and let's do ZIO4. Oops, sorry. And this is going to be the aspect dot render console, my ZIO3. Oh, I should not do that. The definitions. So look what it's done here. It's added the console to the environment, which is what we saw before, but now it's also widened the error type to this IO exception. So just like we want with ZIO itself, we want to be able to use the environment and we want to be able to fail with errors. We'd like what we're doing with these aspects to be able to use the environment or fail with errors. And so having this lower E type parameter lets us do that.
So far we've been lowering, sort of giving an upper bound, specifying, forcing the contravariant and covariant inputs to specify the contravariant environment, right? To require that there is some environment, and then also to widen the error type. I think I have less of an intuition because that's usually what we do in type signatures when you have implicit evidence and you want to make sure oh yeah, you have to widen the either the E or the A or narrow the R. What is a reason for that lower bound on the R, for instance, or the upper bound on an E or an A? Could we look at that?
Yeah.
Maybe, I mean, that's where you're going. I'm just curious. I can't quite have an intuition.
So yeah, let's do an example of that. So for that, let's say that we've got something, say we've got a method called
we have a
update
quick question.
Oh,
I'm sorry.
Yeah. No.
Do you want to install the recommended extensions for Java?
Oh,
Someone asked that.
Thank you.
Sorry, I'm just being silly. Continue.
So let's say we've got some method that, let's call it like update metric. And it's going to, let's say it's going to take some value that's a double, and it's just going to send that metric to some metric service, right? Are you with me so far?
Oh, sorry, I was muted. Yes.
Oh. Okay. So we've got this update metric, and let's say we'll have a specific one that, like this one, maybe to even make this, let's call this, I don't know, let's call it like update temperature, just to be fun. And so this is supposed to update some external service and tell it what is the temperature right now.
Mm-hmm.
So then we've got some method. And what we'd like to do is we'd like to be able to have a aspect that represents this. So we'd like to have something, maybe we call it update temperature. And so we'd like this to be a Z aspect that we can apply to anything. And that's just going to update the temperature with that thing. And so let's think about doing a similar implementation as we had above.
Oh, sorry.
No. So let's, and clearly we're right now we're not going to deal with any errors. So let's go back to kind of a simpler example.
Mm-hmm.
And so what we'd like to do here is we'd like to do something like we'd like to say, okay, well, take the ZIO and tap it and update temperature metric. That seems like quite nice.
Mm-hmm.
And so here we're getting another error. And the error is saying this update temperature metric is a function that expects a double.
Mm-hmm.
But all we know is that this thing is an A. So let's try doing just with the lower parameters. So we could try saying,
Yes.
but that doesn't do what we wanted to do, because what that says is it's not any more specific than a double. But that doesn't solve our problem, because that means it could be like any, or it could be a string or anything else. We actually need the opposite of that. We need to know that it is more specific than a double. And I mean, in the case of double, there really is no subtype of a double, because it's just that one thing. But we need to know the opposite. We need to know that the highest type, but it's more specific than a double. And so now this will work for us. And so that's when we generally need that upper parameter for these two type parameters, is when we want to do something that requires some knowledge of them. So another example would be if we want to do some error logging, and we want it to be like structured error logging, where like this is error logging that knows about domain errors and knows exactly how to log domain errors. We need that aspect to only be able to handle things that throw domain errors and don't throw other errors, because we don't know what to do with other errors.
I see. So when we need to know some information about what we're getting in on this on the input side, we need to sort of, on the covariant types, specify that here if we want to be able to use them.
Exactly.
And here is where we sort of, if we introduce or
Exactly.
transform it or change it somehow, we need to use the lower bound. That affects sort of the outgoing. What about, it is the same, so how does that
I
apply?
don't think I've found a case for using the lower parameter here. Partly there's some value, I think, in symmetry of like, you know, not like just missing one of the six. But yeah, I would say generally the ones I use the most is the upper bound on the environment to introduce the environments, and the lower bound on errors to introduce possibilities of failure. And then sometimes I'll use these upper bounds here if I need to know something about the type, like in this update temperature metric situation. I would say those are the most common ones I see.
Would there be a case for the lower bound on A occasionally?
So that would be the equivalent of the E of introducing a new type. So there could possibly be like, you might have a case where, like, let's say that you had a aspect that was like with default value. And it's going to, so like Nick can do something.
Oh, I think that makes sense. Yeah.
Right, you have like seal trait results, and you could have like final case class value found, and then its object, say default or something, right? And you want to kind of introduce some possibility that you're going to like widen, right? That maybe it filters them. It says, well, if these are negative, then like replace it with the default value. And so you would widen the type from like a value found to a result.
I see. Yeah.
That one I would say also you tend to use less of, because you tend to go back to the idea of separating the what and the how. I think the error type becomes more common because a lot of times, as part of doing something of like logging something or writing something to a file, you might introduce a type of failure, but you don't typically change the result type. So I'd say that would also be less common.
We got a real question as well a while ago, which I was wondering if maybe this would be possible. And now I'm thinking not. I thought maybe it was related to the lower bound on the environment. Is it possible to eliminate environment dependencies? Can you provide?
Yes. That is a great question. So that was the topic of significant research, and we ultimately found, so with this encoding, it's not possible to eliminate the environment because you're saying you have to accept anything and you give back the same type. And because the environment's contravariant, we can always require more, but we can't forget requirements we have because they are actually things that we've said we need. There's another encoding that you can try to use that would allow you to eliminate the environment type, but I would say it adds a couple of degrees of complexity beyond this. I think you've seen this. This is the same one that we used in Z pipeline in an earlier iteration. And basically it involves, in addition to having these bounds, you also have 3 type level functions.
Woo, type level. Yeah.
Z aspect ends up looking like, let's see, where we have Z aspect. So maybe I'll just make another example. I just want to screw this one up. But we would have something like Z aspect complex, and then it would say it has some type out R of R, type out E of E, type out A of A, and then given this REA that's in the bounds, it doesn't actually return you back the REA, but it returns a out R of R and an out E of E and an out A of A. And it adds a lot of complexity to the implementation of these things, and in some cases some type inference issues. And I think overall I mean, it would really be nice if kind of everything could be done with these aspects, particularly for like ZIO tests, so you didn't have to like do the like dot provide layer on the tests. But the degree of complexity, I think, is just not worth it.
Yeah. I think I'd agree. Cool. Yeah. So it's just a lower R. Is there any sort of, can we fabricate something? Can we contrive something that would involve a lower R? Or is that just, I mean, it's nice to have the symmetry, right? So just, what's what, upper R, lower R, upper E, lower E, upper A, lower A. But I'm wondering.
Yeah, I can't really think of a case where you would use the lower R.
Okay. Yeah. What would that mean? That would mean that
that there's some environment that is too specific that you cannot accept it.
Yeah. So yeah, you're able to set the most specific it could be. So if you put console there, it could only have console. It couldn't have anything else. But generally with the environment, it doesn't matter. It's like a map. Who cares if there are other fields in it?
Exactly.
It's not going to bother you. You're not able to provide anything anyway. So why would it matter? And maybe if you were able to provide something, you'd know that if you only had console and you provided console, then you'd end up with any. But,
right. But we can't do that.
You can't provide. Then if you can't provide, then you can't provide. I don't know.
Can't provide. Cool. Well, good are you to me?
Exactly. Maybe remove. What are your thoughts on deleting it and bring it down? I mean, the sexofunctor is that sounds pretty cool as it is currently.
Yeah, I kind of think there's a value in having the symmetry for education. So I kind of feel like having 5 would be weird.
Gotcha.
But so I think that kind of hopefully gives you an idea of what you can do with each of these type parameters and what you can do with aspects. The other thing then you can do with these is if you have a concrete data type, you can implement the syntax. So we could do like implicit class Z aspect syntax. Oops. This could take an aspect, and I'll just grab my oh, actually, I don't want it here. Sorry. This is going to be on a ZIO, let's say. And maybe to avoid conflicts, maybe I'll make this 3 ats. And now I'll take all of my little type parameters. And here I'm going to do all my little constraints that are lower R is a subtype.
Oops. Okay. Oh yeah, it's backwards. Let me just get back as ZOREA, just the same, right? Yeah.
Yep. And let's see.
Why is that sad? Oh, it needs to be the same. Oh, private val? Does it need the?
It doesn't need to be private, but I think it needs to be a val.
Yes.
The private is just best practice.
Let me format this. There we go.
Yeah, and so now let's see if I could do something like my ZIO3 add in the console. And let's see, what's this? Did we?
Well, what about the logging one or something? Oh, it's inside of Z aspect, and we might be outside.
Oh, that's not gonna help me. Okay, let me pull that out then.
Is it? Yeah, maybe.
Yeah, I'm not sure. Let's see. I may also do something silly, but.
Or is this inside of Z aspect? I think the render console might be inside of Z aspect. No.
Oh, no, it doesn't seem to be seeing that.
Inferred arguments do not match. Interesting.
Interesting. Yeah, let me.
Oh wait, did render console need? No ints there.
Let's take a look at this. Oh, interesting. Okay. I think I need to be slightly fancier with this.
Oh, flip them around?
No, we kind of need to do this because we're using the implicit syntax, it's not as good at narrowing the types. So we need to be a little bit fancier here. So we do, yeah, E is this. I'm just gonna copy this. Yeah, we need to do a little, oh, perfect. We do a little bit more working around this just because we're using an explicit syntax class, I believe. Let's see.
I found upper R, lower E, lower A for some reason.
Yep.
Oh, okay. Oh,
yeah, so this is just kind of getting a little bit fancier just because when you use this implicit syntax, it doesn't, it's not as good at narrowing or widening the types for you. So this kind of is us manually doing it. But now you'll see we get to a similar thing here of like, I had this original effect that didn't need an environment and couldn't fail at all. And I applied this render console that used the console and could fail with an IO exception. And I get back a new effect that needs a console and can fail with an IO exception, but still gives an int.
I see.
So yeah, stepping back, I think first concept to know would be that idea of the how versus the what, and thinking about if you do have some concern that is about the how, that is about what executor you want something on, or how you want something logged, or how you want to chunk a stream, then an aspect can be a really nice solution for you. And in ZIO2, there's, in addition to test aspects for tests, there is a ZIO aspect for ZIO, there's a ZManage aspect for ZManaged, and there's a ZStream aspect for ZStream. And all of those have operators on them. So you can check those for if there's something that takes care of the how that you're interested in. And if not, hopefully with this session, you feel more empowered that if you wanted to implement your own, it's actually not that hard. There are these, yes, there are 6 type parameters, but you can think pretty easily about, and maybe we could even make a little like checklist for you. We could say, does what I'm doing have environmental requirements? Use the upper R. Does it introduce new failure modes? Use the lower E. Does it need to know something about error value types? Use upper E or upper A. And so you could pretty easily implement your own aspect for whatever you're doing. If you want to log it with your own custom logging service that you define as a service, well, you've used the upper R here. If you want to write to a file and you know writing to a file can fail with an error, you can use the lower E for that. If you saw you want to do some kind of structured reporting of errors, or you want to do some kind of metrics reporting where you need to know what those error value types are, you can use the upper bounds on those error or value types. And once you do that and you just plug those into the right place, the action, and obviously there's just a little bit of just like basically just copying the implementation that your IDE should mostly do for you, then your actual implementation is typically going to be very simple and just going to be calling some other operator you've defined somewhere. Like you've seen, we've used this like with annotation thing, we've used tap. Tap is kind of an example of like the operator equivalent of some of these aspect operators. And so you can use this to implement your own aspects if there's something you want to describe for the how of a stream or an effect or a test. And then I think the final level of using this would be saying you have your own data type. You have the HTTP data type from ZIO HTTP, and you want to, in that case, they may eventually do their own, or they've got their own things, but you've got your own data type within your code base that you'd also like to be able to describe ways of transforming the how. And you could implement your own aspect. And you just follow that pattern of count the number of type parameters. For each type parameter, you've got the lower and the upper bound. And you can follow the same pattern to apply this to your own code.
Is it possible to have a constructor that just works basically like, say, for this one? I'm not sure if it would be possible due to the nature of all the type arguments, but that was, .make and then sort of just took a function like this. Is that theoretically possible? That could then figure out the bounds necessary based on the function you passed in, like just a constructor where you didn't have to sort of pre-specify everything?
I think in like certain cases, if you wanted just to be monomorphic, you could, but it gets challenging with, and maybe Scala 3 will help us do this better, but it gets challenging with the limitations on encoding polymorphic functions in Scala, because you want to say that this is something that can take any REA and give you back the same type. Mm-hmm. Versus if you kind of try to make it from a specific function, that's going to be a function that takes one type and gives you back a certain type, not anything for the same type, right? You want essentially get more fancy here, you want a universally quantified function here. And at least in Scala 2, that's not something that there's a easy way to do. So I think on like test aspect, there's a constructor to construct one from something that's monomorphic. And if you have specific things, there can definitely be some helper methods you have, but that's kind of the limitation and why we end up doing some of this.
Okay. Cool. Any other questions in the Discord? We don't have any currently, I believe. Well, someone did ask the default value example, why use that instead of option.get or else, but I think that was, Naveed also answered that, which I think that was a contrivance mostly based on.
Yes, that I think definitely would be a less usual one.
Yeah. But I think we're all good besides that one.
Okay, awesome. Well, thank you so much, everyone, for taking your time. Hopefully this was helpful, and hopefully you can use this in your own code.
Awesome.
We're getting a lot closer to ZIO 2. I think we have versions out for almost all the major ZIO ecosystem libraries. So we've been starting to be able to migrate some of the production code bases we work with. So it's it's an exciting time to try all this out.
Great. Well, yeah, let us know if you have any other thoughts or things we want to cover. Otherwise, we'll come up with something for next week. And we'll talk to everybody soon. Take care, everybody.
Thank you so much, everyone.
Bye, everyone.